variation of electron gain enthalpy in the periodic table. I mean how the electron gain enthalpy changes along a period and in a group. Here this is second period elements. This is second period elements and this is group number 1. Now as you know, in a period from left to right the size of the atom going on decreasing, and as the size of the atom going on decreasing, the electron gain enthalpy value going on increasing, and that is why from left to right the electron gain enthalpy value always increases from left to right. When you consider a group from top to bottom, since the size of the atom going on increasing, that is why electron gain enthalpy always decreases from top to bottom. So it mainly depends on size. Since the size of the atom going on decreasing in a period, that is why from left to right electron gain enthalpy value decreases, and in a group from top to bottom size of the atom increases, that's why electron gain enthalpy value going on decreasing. So this is called the variation of electron gain enthalpy in the periodic table. But this is general one, but there are some exceptional also, because it depends on the electronic configuration also. For example, if you consider beryllium, lithium and beryllium, when you consider lithium electron gain enthalpy less than beryllium less than boron, like this you will get, because left to right left to right atomic size going on decreasing. But exceptionally you will get beryllium. Why beryllium have exceptional character? Due to its configuration. Since beryllium configuration is 1s2 2s2, both are filled up, I mean it has the stable configuration. Due to stable configuration it has no tendency to gain the electron, and that is why you will get more in lithium than beryllium. This is exceptional one. So first you consider the atomic sizes. After considering atomic sizes, you see the electronic configuration also. If some electronic configuration have some extra stability, then the you may get the exceptional character for that type of elements. And generally from left to right it going on decreasing, and from top to from left to right it going on increasing, and from top to bottom it going on decreasing. But there are some exceptional cases due to their configurations. If the atom have some stable configuration, then you will get the exceptional character. I will tell you the exceptional character which can show exceptional case. The first thing is one question may be asked: fluorine, chlorine, bromine and iodine, you know, these are present in group 17, and group 17 they always have 7 electrons in their valence shell. For example, fluorine configuration is 2,7, chlorine its configuration is 2,8,7, bromine its configuration is 2,8,8,7. Like this you will get the configuration. Now since they contain 7 electrons in their valence shell, due to presence of 7 electrons they have always tendency to get 1 electron, and that is why they have high tendency to gain the electron. And since they have high tendency to gain 1 electron to get the stable configuration, that is why this type of elements, I mean halogens, they have always higher electron gain enthalpy. In our modern periodic table, noble gases have the highest, halogens have the highest electron gain enthalpy due to presence of 7 electrons in their valence shell. Always remember this. If you compare the elements, halogens always have highest electron gain enthalpy value due to presence of 7 electrons in their valence shell. Suppose some configuration is like this 2,5. It contains 5 electrons in their valence shell and it contains 7 electrons in their valence shell. Definitely it requires 1 electron, it requires 3 electrons to get the stable configuration. Since it requires only 1, that's why fluorine have more tendency to gain the electron as compared to this element, I mean nitrogen. And that is why fluorine electron gain enthalpy value is more, I mean it will release more amount of energy than nitrogen. And always remember one thing, those elements which can gain the electron more easily, that type of atom will release high amount of energy. and if the atom cannot gain the electron easily, that type of atom releases lower amount of energy. That is why it mainly depends on the configuration. Those configuration which have high tendency to gain the electron, that type of atom always releases high amount of energy, because after gaining the electron it gained a stable configuration, and due to gaining of stable configuration it always release high amount of energy. So always remember, halogens, they contain 7 electrons in its valence shell. Due to presence of 7 electron, it always have the tendency for 1 electron to get the noble gas configuration, and that is why when it gain 1 electron, it get the noble gas configuration, and after getting noble gas configuration it releases high amount of energy, and that is why electron gain enthalpy value of halogens are highly negative. Highly negative means they release more amount of energy. Now, if you want to compare fluorine, chlorine, bromine, iodine, as I have told you, down the group size of the atom going on increasing, that's why electron gain enthalpy value going on decreasing. So that is why according to that, fluorine should have maximum, then chlorine, then bromine, then iodine. But here you will get one exceptional case. The highest electron gain enthalpy value you will get for chlorine, not fluorine, although fluorine is smaller in size. And this question is very important question. Why chlorine have higher electron gain enthalpy than fluorine, although chlorine is larger in size? So I will explain that. You know chlorine, it contains 3 cells, first cell, second cell, third cell. 2, 8, 7. I mean first cell 2 electron, second cell 8 electron, third cell 7 electron. And in case of fluorine, it contains only 2 cells, first cell 2 electron, second cell 7 electron. This is chlorine, this is fluorine. Since the size is small, so the nucleus can attract the electron more. But here, since the size is large, so the electron cannot be attracted by the nucleus more as compared to fluorine. So according to that, fluorine can gain the electron more easily as compared to this, but no, chlorine can gain the electron more easily than fluorine. So why it is like this? You know second cell, how many electron present? 7. And second cell contain maximum how many electron? 8 electron. Already how much present? 7. So only the space is present for 1 electron, because second cell contain maximum 8 electron. Since already 7 electron is present, maximum spaces are filled by the electrons. The space is present only for 1 electron. When the electron is coming to the cell, some inter-electronic repulsion takes place due to the between this incoming electron and the electrons already present in the valence shell. But here, how many electrons are present? 7. And you know this is third cell. Third cell contain maximum how many electrons? 18 electrons. But how much present? 7. So that is why maximum of spaces are vacant here. That is why when the electron enter in the cell, the electron can enter easily. There is no such inter-electronic repulsion between this incoming electron and the electron already present in the cell. So since the second cell contains 7 electrons in fluorine, that's why some inter-electronic repulsion takes place between this incoming electron and the electrons already present in the valence shell, and due to which the electron cannot enter the second cell easily. But due to presence of third cell, since third cell contains maximum 18 electron, only 7 are present, so maximum of spaces are vacant. That's why inter-electronic repulsion is less, and so chlorine can gain the electron more easily than fluorine. This will happen in case of oxygen and sulfur also. Oxygen is 2,6, sulfur is 2,8,6. But sulfur higher electron gain enthalpy than oxygen. Why? Here also inter-electronic repulsion takes place in between the incoming electron and the valence electron. So that is why you will get some exceptional cases, and that exceptional cases you should know. Although this chlorine is larger in size, but the electron gain enthalpy of chlorine is more than fluorine due to this inter-electronic repulsion. Some inter-electronic repulsion takes place in fluorine, but this type of inter-electronic repulsion you don't get in chlorine, and that is why chlorine have more electron gain enthalpy than fluorine. If you consider noble gases, for example neon contain 2 cells, first cell contain 2, second cell contain 8. The cells are already filled up. In this type of case, if you want to enter electron in second cell, since it is filled up, you have to enter the electron in third cell, I mean in higher energy cell. In case of higher energy cell, you have to supply energy, and that is why instead of releasing here, you have to supply the energy, and that is why noble gases electron gain enthalpy always represented by positive sign, because you have to supply the energy, it will not release the energy, because you have to enter the electron in higher energy level. So that is why noble gases electron gain enthalpies are always positive. Thank you.